So again, good morning everyone. Today we'll be starting new chapter which is trigonometric functions. We have already studied this topic which is very simple. Right now I'll be covering. You would have studied it in 8th or 10th maybe. So it's just a revision. You will know already knowing it. One right angle is always 90 degree and 1 degree is equals to 60 seconds and 1 second is equals to 60 milliseconds. This is how we represent, right? Pi is equals to this 22 upon 7 approximately. Basic things, pi is an irrational number. 180 degree is equals to the pi radians. Pi is 180 degree. 1 radian is equals to pi 180 upon pi, which is this 206,265 seconds. Yeah, that's it. This is not important. I don't think anything will be asked, but still you can see if you wish. And suppose this is something like that circle. We are taking just the theta part of it. The radius is r, then this is l. So here the equation is theta we can find by just by l and r. This is very simple. Second is we'll be studying trigonometric ratios. We already know sin theta is equals to p upon h, cos theta is b upon h, tan theta p upon b, cos theta h upon p, sec theta h upon b, cot theta b upon p. This is very simple. You always have it. There is a trick also. This is sine theta, this is cos theta, this is tan theta. Simple. Just inverse it, you'll get the cosec, sec and cot. You know what is sine means? Sine is nothing, it's just the sinusoidal. Since the graph of this function is sinusoidal, so it's called sine. Instead of sinusoidal, we call it sine. And cos is cosine. That is the cosine figure that we get. Basically sine starts from 0. Then when starts from 1, this becomes cosine figure. Tan means tangent. It tells you this is in figure that then tangent at it. That's why it's also called slope. I would have already known it. Next is sine of t ratio. Here, like in the first quadrant, if theta is in the first quadrant, then all the things will be positive, whether you find sin, tan, sine, cos, whatever. In second, only sine is positive. And sine ka inverse is cosec. Cosec will also be positive. So you just have to remember that sine is positive. Cosec will automatically be positive, because it's inverse. Tan is positive, then definitely its inverse. Cot will also be positive. Here in fourth quadrant, only sec is positive. Rather than this, others are negative. Yeah, now we're talking about the domain and the range of the trigonometric equations. This is very important and most of the students get, very confused. So try to understand and learn it because it's very basic and even if you use a little bit of your brain, then even you don't have to remember it also because it's so it makes sense and it's very simple. For sine theta, any r you can take. This is the graph for the sine theta now. You can take anything in sine theta. So this is the graph of the sine theta. You can take all the real values and you get the y-axis for that. When in cos theta, again cos theta also all tan. But in case of tan, this is something the graph for tan. So you don't get for everything. Right. Yeah. The r minus the opposite pi by 2. It is at that point it is infinite, so we don't get it. That's why it is minus. We are subtracting it. Cos, we just have to subtract when tan is 0. Tan is 0 at every 0, right? So at 0 and pi, every multiple of pi, tan is 0. That's why we are subtracting and pi, because otherwise it will become infinite. Then cosec is r minus n pi. Sec r minus 2 n plus 1 pi by 2. And range sin theta is between the 1 and minus 1, cos again 1 minus 1 1. Tan theta it's from minus infinite to plus infinite. Cos theta it also minus infinite to plus infinite. Cosec theta minus infinite to minus 1. then you are integrating 1 to infinite. From minus 1 to 1 it is sec. That's why it cannot be, I mean it was sine. That's why cosec we have no, we don't take minus 1 to 1. Similarly for the sec also in cos we have minus 1 to 1. That's why we don't take between this. It's very simple to remember. If you if you remember it, it's a trick. Like if this is there, it will not be there in this. That's very simple. Next part is finding the maximum and the minimum value of the trigonometric equation. So sine theta are definitely 1. Just go through it. It's very simple. I told you now, it ranges from minus 1 to 1. Then 1 will be the maximum. This will be the minimum. It's very simple. Knowing this, here, what will be the maximum? Infinite will be the maximum. Minimum, minus infinite will be minimum. So it's simple. You through this only, for the range you can get this. It's very simple. We reach to E part now. Since sine theta plus cosec theta will be equal to 2. If sine theta is equals to 1 and cosec theta is equals to 1. See, if this is the condition, then this implies that only this is possible only when sine theta and cosec theta is equals to 1. Otherwise, it's not possible. This is the condition. And cos theta plus sec theta is equals to 2 only when this is the condition. Two conditions are there. Cos power n theta plus sec theta ki power n should be also equal to 2. That's what it is. It's not that important, not used a lot. I have rarely used it, though I have solved many questions from this chapter, but none question was from this. So 0% I would say. That's why I'm saying don't study this. But since I'm not missing anything, I don't know why they gave even this formula. Now we are with the compound angle formulas. This is very important. Very, very, very important. Sin theta plus sin A plus B is equals to sin A cos B plus minus cos A sin B. If it is plus, then it will be plus. If it is minus, then it will be minus. Cos A plus B. Minus also. Cos A, cos B. The trick is with the cos, we have cos together, and sin we don't have together. That's the only difference. For the tan theta, it is A plus minus B. Tan, if it is plus, then upper it will be plus, and niche it will be negative. If it is negative, upper it will be negative, otherwise niche it will be plus. Cot A plus B is just the opposite of this, like cot A, cot B. If it is plus, it will be minus 1. And here it will be cot B. If it is plus, it will be plus. That's it. Sin A plus B, sin A minus B is equals to sin square A minus sin square B is equals to cos A square B minus cos A square A. It's very simple. Cos A plus B, cos A minus B is equals to cos square A minus sin square B, cos square B minus sin square A. Tan A plus B plus C, tan A plus tan B plus tan C plus minus tan A tan B tan C. 1 minus. You just have to remember it was minus over here. Signs should be taken care of, very important. These signs are very important. Now we have transformation formulas. As you can see, transformation formulas are also very important. 2 sin A sin B is equals to cos A minus B minus cos. If you don't know these formulas, the transformation, compounding the formula, nothing, bro. You cannot even start trigonometry. This is taught in class 10th, and I hope everybody already had learned till now. If you have not, wake up whole night and learn it. Otherwise, don't even dream of anything. 2 sin A sin B is equals to cos A minus B minus cos A plus B. It's very simple. Cos A cos B is equals to cos A minus B plus cos A plus B. 2 sin A cos B is equals to sin A plus B plus sin A minus B. 2 cos A sin B is equals to sin A plus B minus sin A minus B. Second part of the transformations formulas. Sin C plus sin D is equals to 2 sin C plus D upon 2. Cos C minus D upon 2. Sin C minus sin D is equals to 2 cos C plus D upon 2. Sin C minus D upon 2. Again, with the sign we have 1 cos 1 sin, but with the sign, both the sign, again we have cos 1 sin, but with the cos we have cos only, with the cos we have sin only. So you've seen the trick that I told you was like with the sign only you have both sin and cos, but with the cos we have either both sin or either both cos. Then in plus it was both cos, in minus it is sin. I hope Now you have got the trick to remember it also. Now we have reached to multiple angle formulas. These are also very important. Like sine 2a can be represented to sine a cos a. These formulas get used up anywhere in the questions and you don't know where they are going to get used. So remember it by heart. It should, like, if anybody says sine 2a, you should automatically remember sine a cos a. Another form also, 2 tan a, 1 plus tan square a. According, like, whatever you're proving, whatever the question is, using by that formula you will use either this one or this one. You have to get it yourself which one to use accordingly to prove that particular thing. Okay, next is cos 2a. Cos square a minus sin square a is equals to 2 cos square a minus 1. This can also be written as 1 minus sin square a. Yes, of course. And this is also 1 minus tan square a upon 1 plus tan square a. Again, minus is Sin 3 is represented at 3 sin a minus 4 sin cube a. There is trick again for this also. Like for the science students, they have very less money, but after that they have huge money. So cube is afterward, and here without this they don't have cube. And 4 is afterward. 4 and 3 both are given more than 3 and 1. That's why. And cos 3 is what? C for commerce. So commerce students, first of all, they get very good, nice job, but after that they ruin their life. I mean, they don't have anything to do. That's what it is saying. That's why it was 3, and then before they had 4 and 3, but later on they get only 3 and 1. That's why it's. This is a trick. If you want, you can learn it by using this. Tan 2a is equals to 2 tan a upon 1 minus tan square a. This is also important. This is similar to the tan we have studied, tan a plus b, tan a plus tan b, 1 minus tan a tan b. So you just have to put these formulas. If a, b both are equal, then it becomes 2a. b, it gets added up like this. Similarly, cot 2a also cot square a minus 1 upon 2 cot a. Simple. And here tan 3a is equals to 3 tan a minus tan cube a upon 1 minus 3 tan square a. And cot 3a is equals to 3 cot a minus cot cube a 1 minus 3 cot a cot square a. Remember all these formulas by your heart because these are very important. Now we're starting with the F part. So sweet little values and identities. Okay, it's no more sweet because you have to learn it like a lot. See, sine 15 is equals to under root 3 minus 1 to root 2. You have to use, like, there are formulas like sine 15 plus, maybe you can use 30 minus 15. Not this also. But you just have to take it this form something, and then you have to find it. It's very bad, but still. So you have to take that. It's better you learn it because it's take time to solve all this. But I can tell you, like, sine 15 is equals to cos 75. How it becomes? See, there is a trick for this. Like, if it's on the vertical side, 0 pi pi 2 pi 3 pi by 10, right? So if it is on the vertical, then the sign, then it will get inverted. If it is sine, it will become cos. If it is cos, it will become sine. And if it is on this, then sine will remain same. And how you based on sine will be like here all positive. Only sine is positive. Tan is positive. Cos is positive. And its inverse be like sec theta will be also be positive. Tan theta and cot theta will also be positive. So yeah, this is the, we're talking about sine 15, right? So you can write it like I hope it's clear now. So you can write sine 15 as sine 45 minus 30, right? You'll solve it using like this and you'll get this one. So sine 15 can also be written as sine 90 minus 75. So it's on this, and 90 is this. So it's reaching some 90 minus 73. So it is 90. That means it's on this line. That why it will get inverted. Sine will convert into cos. Invert of sine is cos. Cos convert is sine. Tan convert is cot. That way. So sine will change into cos, and 75 will remain same. And in this 90 minus this, so it is talking about this quadrant, right? Because it's 90 minus 75. Here all are positive, so even cos will be positive, so it will be always positive. So this is the trick to solve these kind of questions. I hope you are getting it. Just go through one by one. Tan 15 under root 3 minus 1 under root 3 plus 1. Tan 75 under root 3 plus 1 upon under root 3 minus 1, like these. This is important. Sine 15 was important. This tan is important. You remember one thing, other will be automatically remembered. Similarly, if you remember this one, these two will already be remembered by you, right? These two are very easy. Now we have is the range of the expression of sine ax plus b cos ax is this. You have questions, very important questions, especially in advanced, in mains, you have these kind of questions where you have minus a and you have been given like this sort of equation and you have been asked to find its range. So in that case, the range will automatically lie between these two, and it's like a formula, as you can learn it, and then whenever question comes you can directly solve it that way. So it becomes very easy. And now we'll be talking about some of the trigonometric series, like sine alpha plus beta plus sine alpha plus 2 beta plus sine alpha plus till n minus 1 beta. It becomes sine n beta upon 2, sine beta upon 2, sine, this will be alpha, and the last part n minus 2 beta by 2. Only last part you take and b by 2 kar do. This is a trick. Take the last part, b by 2 take it. In the same way with the cos theta plus beta, cos theta plus 2 beta, like that, then plus cosine n beta upon 2 sine beta by 2. It remains same like these, but it changes. It becomes cos and a n minus 1 and again beta by 2. Same things are there. Now we'll be talking about general solutions. So if sine theta is equals to sine alpha, in that case theta will be represented in this form where n can be any real number. Cos theta is equals to cos alpha, then it is 2n pi plus minus alpha. Tan theta is equals to tan alpha, then theta is equal to n pi plus alpha. Okay, because one solution can have like this equation has lots of solution, infinite number of solutions. So, and you can have infinite number of solutions like these. Okay, all the three can have infinite number of solutions. So we can just find one. One is the principal value solution which occurs between 90 and 0. If you can get that, that's okay. So yeah, we are ending this chapter, which is trigonometric functions. So yeah, thank you.